Hi everybody and welcome to Unit 2 notes. First thing that comes up in our notes is that you will need to know the elements by name and symbol for the next test, and as you start learning those, realize that in your packet you have two periodic tables. You have this first one here which gives you a lot of information including the names and all of that good stuff. Your second periodic table is actually the one that you would be getting on tests. Has a lot of information on the back which we're going to use in future units, all right? But I'll be referring to both as I go through our notes today. All right, great. So, classifying matter, all right? Matter is defined as anything that takes up space, all right? We, in chemistry, classify matter into two main groups. The first being substances, and then the second being mixtures. In this unit, we're gonna focus on substances. When you describe something as a substance, it means it's either an element or a compound, all right? So let's move down and let's talk about this a little bit. All right, so before we start talking about elements and compounds, let's just talk about in general how we describe matter. All right, well, we describe matter using its properties, and there are what is known as intensive and extensive properties. All right, so extensive properties depend on the amount, and we dealt with this a lot in the last unit. Things like mass, volume, and length. That depends on how much you have. An intensive property depends on the type of matter you're dealing with, not how much. This property is going to stay the same regardless of how much you have. Things like melting point, boiling point, and density are all intensive properties. Both extensive and intensive properties are typically described as physical properties, a condition of a substance that can be observed without changing the substance. So all of those above, you're not changing that substance. A chemical property, however, describes how one substance reacts with the other. All right. So for example, zinc reacts with hydrochloric acid to produce hydrogen gas. That would be a chemical property of zinc. All right. Okay, so let's get back, all right, to some basics that you guys should already know. All right, we also describe matter talking about whether it is in terms of a solid, liquid, or gas. All right, so solid will in chemistry get the abbreviation a lowercase s or CR, which stands for crystalline, okay? So either one, we know solids have a fixed shape and fixed volume, whereas liquids, which get the abbreviation lowercase l, take the shape of the container, but their volume stays the same. So if you have a liter of soda, all right, that liter is gonna be the same whether you have it in a large bottle or let's say you decide to pour it into a bucket or something like that. The volume stays the same, the shape will change with the container. Gases, which get the abbreviation lowercase g, take the shape and the volume of their container. All right, we'll study a lot more about gases as the year goes on. Okay, so let's talk about our substances. As we said before, substances are broken into two categories, elements and compounds. When we refer to an element, we are talking about atoms. And atoms of the same element always have the same number of protons. Put a big star highlight by the word protons. That's what gives elements their identity. Elements cannot be broken down through a chemical reaction. We use the abbreviation for reaction is RXN. All right, so this is reaction. And elements cannot be broken down by chemical reactions. Some can be broken down through nuclear reactions, but not chemical reactions. All right. Elements come together to form compounds, and we say that compounds have a definite composition. And what we mean by that is if we're talking about the compound water, all right, that water is going to have the formula H2O. There's 2 hydrogen atoms for every 1 oxygen atom. All right, and that's what water has to be. As opposed to H2O2, which is called hydrogen peroxide, which a lot of us have in our our medicine cabinets because it's used to disinfect cuts and things like that, but you certainly would not want to drink hydrogen peroxide. All right, this would be very, very bad for you if you drank it. We drink water all of the time. Both are made up of the exact same type of elements, but in a different composition. Compounds, unlike elements, can be broken down through a chemical reaction. All right. right? But that is the only way to break them down, is through a chemical reaction. And we're going to look at all of that, those a lot more as the year goes on as well. All right, so let's talk about the atom. And what I'd like you to do is take a moment, pause the video, and fill out this chart. All right, great. So atoms are composed of subatomic particles. We should know this from former science classes. All right, we have in the nucleus protons and neutrons. Surrounding that nucleus, we have electrons. What I've given you is the masses of these, actually in grams, and you can see it's an incredibly small mass. We don't use these numbers because they are so tiny. Instead, when we're talking about the mass of subatomic particles, we use a unit called AMU, which is atomic mass unit. The mass of a proton is considered 1 atomic mass unit. Neutrons have the exact same mass. Electrons, while they have mass, they exist. If you look at this number, this is quite a bit smaller than our protons and neutrons. So what we say for the mass and AMUs of an electron is that it is so small that we don't really consider it to have mass. All right, so we say that the mass and AMUs of an electron is 0. The charge is very important. Protons are positive, that's why I have a little p with a positive sign there. Electrons are negative, and neutrons are neutral. They do not have a charge. Here's where we find them, protons and neutrons in our nucleus. Electrons are surrounding that nucleus in what we call the electron cloud. Atoms get their identity from their number of protons, and we call this the atomic number. I'm just going to bring out your periodic table here for a moment. All right, and right here on any periodic table, at the top, you are going to see a whole number. All right, it's always at the top, and if you notice, the periodic table is arranged 1, 2, 3, 4 by that atomic number, and that represents your number of protons. All right, great. Okay, so let me scroll down a bit. Okay, when we use the word atom, all right, when we use the word atom, it is assumed that you have a neutral substance. So what do I mean by that? It means that it is electrically neutral. So if I use the word atom, your number of protons and your number of electrons must be the same. All right. So for example, oxygen, I look at the periodic table and I see that oxygen has an atomic number of 8. All right, coming back here, yeah. Great, oxygen, atomic number of 8 right there. So that means that it has 8 protons. It is an atom of oxygen, so therefore it has 8 electrons. Great. Now, so we know how to find the number of protons and the number of electrons. The next thing is finding the number of neutrons. In order to find the number of neutrons, we're going to look at the mass. All right, because the mass of the atom, as we just talked about, is simply composed of the number of protons plus the number of neutrons. All right, if you look at, again, your periodic table, and we'll look here at oxygen, we'll stick with this one. You have the atomic number on the top, and then there's a number on the bottom. That number is the atomic mass. All right, another way to show that is to draw it O-16. This represents the mass. We call that the mass number. Well, since the mass is 16, and we know that that 16 comes from your protons and your neutrons, we already know the protons are 8 because we know the atomic number is 8. 16 minus 8 gives you 8. That's your number of neutrons. All right, fantastic. Okay, now, next thing in your notes, I've got to scroll back up, is talking about kind of the visual for our atom. This is what is known as the Bohr model of the atom. And you want to take a second and pause and kind of jot this down. This is the traditional model that we're used to looking at. And it's where your protons and your neutrons are in the nucleus. And then your electrons, all right, are around the nucleus in these different electron levels. Okay. The Bohr model is not the modern atomic view. We're going to talk about that in our next set of notes, but it does give us a really good visual to kind of start our understanding of the atom. Okay, fantastic. So now let's talk about something that are called, our last topic for today, something that's called isotopes. All right. Now, let me be very clear. If you are talking about an atom of oxygen, it will always have 8 protons because that is its atomic number. The number of neutrons, however, can change. And when that happens, we say that we have isotopes. So for example, all right, yeah, I can have neon 20, neon 21, and neon 22. When you look at your periodic table, you should see that neon has an atomic number of 10, which means that it has all neons. If you call it neon, it means it will have 10 protons. So then we can figure out our neutrons, all right? So if I'm neon 20, okay, my protons and neutrons are going to be the same because I know that's 10, and 10 plus 10 gives us 20. Neon 21 is going to have 11 neutrons, and neon 22 will have 12. All right, go on ahead, please, and do the example for oxygen. Pause the video. All right, so let's take a look at the answer for our 3 isotopes of oxygen. We have oxygen 15, 16, and 17. Our protons for any oxygen, as we talked about, is going to be 8. Our electrons, because we are talking about atoms, are going to be the same. And then what changes is my number of neutrons. Oxygen 15 has 7, 16 has 8, and 17 has 9. Fantastic. All right, our last thing we're going to talk about, and you need your testing periodic table here. If you notice the mass numbers on this periodic table, they have decimals. They are not whole numbers. That is because these are what are known as average atomic masses. All right, an average atomic mass is what we call a weighted average. So on your periodic table, on the testing one, and on most periodic tables you look at, you have what are known as weighted average for all of the isotopes of a particular element. So a weighted average, remember, keeps in mind how abundant, how often that particular isotope occurs. All right, so remember, if we're doing, most of the time when we do our averages, we are doing weighted average. If I'm averaging how you guys did on a test, I look at all of the different test grades and how many people achieved those grades. That is a weighted average. So let's just talk about how we're going to do that and what that's going to look like. All right, element X has 2 isotopes, X10 and X11. X10 occurs 19.91% of the time, and X11 occurs 80.09% of the time. What is the average atomic mass of X? Well, you should first just kind of look at these numbers and think to yourself, well, X10 occurs about 20% of the time. X11 occurs about 80% of the time. Their weighted average, it's not going to be 10.5, right? No, that would just be the average of 10 and 11. It's going to be weighted, so it's going to end up being closer to 11 than 10. So let me show you how mathematically you do this. It's nice and easy. You're going to take the isotope number, so X10, you're going to take that mass number. You're going to multiply it by the percentage of time that it happens. Now it's a percent, so I just move that over 2 times. All right, because a percent, remember we multiply by 100 in the end. I'm taking that away to make it nice and easy. So I'm going to multiply those 2. I'm then going to take 11 and multiply it by its abundance. Again, where did I get that 0.8009 from? It's 80.09%. Move that over twice. I'm going to multiply those 2. Then you're going to add whatever you got for this one, the product of this, to the product of this. You already know your answer should be somewhere between 10 and 11, and it should be closer to 11. So let's take a look at that. And our answer is 10.8 AMUs. I'm not going to be worried about significant figures with this. However, because we're doing weighted averages, you absolutely must have a 10th place. All right, we're going to get a lot of practice with this. So have a great day and make sure these notes are filled out. Take care. Bye-bye.